In many of the woodworking projects we develop, creation of a cut list and or bill of material is important for the consideration of materials to be used, size, what to order, and in general what the cost possibly could be in the development of any particular project. Inventor has tools inside of it that will allow us to create that automatically and can be developed to be quite extensive. We've also found many third-party products that will allow us to develop them quickly also, and at the same time develop an Excel spreadsheet specific to that particular application that we're working on. We're now ready to create a cut list or bill of material for this particular job. Utilizing one of the many third-party tools that are available for Inventor, we are allowed to just pick a single button and it will produce an accurate bill for us. At this time, we can also assign order numbers or code numbers to it because we might want to export downstream to a spreadsheet, to an MRP or ERP system, or just for printout. Once doing that, we'll get a listing of all the parts that have been associated with this particular job, the quantity, the length, width, and thickness of each of the materials, and of course the material used. As you can see, we have length, width, and thickness already associated in this particular job. On top of that, every place where we used edge banding, you will also have a listing of the edge banding. So, taking a look at a particular part, we can open up the part, we can see the edge banding, we can see the name of the edge banding, the material used, and the fact that it has reduced the size of the blank by the thickness of the edge banding. Again, something that really is an automatic feature that we don't have to address. It also will show any of the materials that were used as we were creating the project itself. If we then change the depth of the cabinet by going back to the master part, we change it to say 12 inches. Okay, the depth of the cabinet changes to 12 inches. The master assembly changes when we do an update to 12 inches. And of course, in almost all woodworking projects, we are asked to add items to the particular job, thus the assignment and placement of hardware. Now, it's not only hardware, but joinery also. That means the addition of dowels, biscuits, pocket screws, mortise and tenon joints, dovetail joints, shelf pin holes, all are hinging and are attaching mechanisms. And we can either do that up front as we're building, which sort of locks us in quite a bit to what was originally decided, though we can move it, but it could be somewhat time consuming. The workflows that we have come up with, I think, will help us do this much quicker, more accurately, and more consistently. So let's get right back to the model. It's now time to add some hardware to our particular project. The first thing will be to add some shelf pins. So we'll go to the Place tool and we'll place from our library. And we have an extensive woodworking library that we've developed over time. All the different items that we use commonly on multiple jobs. And one of them, of course, will be shelf supports. Shelf supports, we've put together a little bit different type of library than most. And our shelf supports come in as an I family or an I assembly. And you'll see that by placing it, we'll have the ability to either tell it that we either want 1, 2, 3, 5, 7, 9, or any number I decide to put in here that I use in a common practice. Then trying to keep consistency between jobs. Once it's located within our particular project, you'll notice also that the library item is made up of not only the support for the shelf pin itself, but the grommets themselves that plug the holes that get generated, and also the negative shape that's in blue that's going to cut into the vertical member that the pins will attach to. So a lot of things are going to happen at one time rather than worry about it. each of the individual items later on. And we're doing it after the fact, after it's already designed. So we're going to get things to line up perfectly. Well, the first thing I do is I take a plane using the plane tool, and I'm going to say 2 inches in from the front is where I'm going to ride my first set of pins or set of holes. And then I'll say 2 inches from the back will be the other set of holes. So by using work planes, I'm going to locate exactly where the pins go. Now, second step, utilization of iMates, but iMates a little bit differently than what we've done previously. So one of the tools we add on to our system is the ability to attach hardware. And the only difference between this and normal iMates is that we have the ability to either singly place it one at a time or multiply place multiples at a time. So in this particular case where I have so many pins to do, I'm going to multiply place my pins, and it's going to query me 3 questions. The first one is pick the internal side that I'm drilling on. So I'll pick all 4 sides of each of the vertical panels, okay? So I am now going to place somewhere in the neighborhood of 18 times 4 number of pins into this model at once. It then will prompt me to pick the bottom of the shelf, okay? So it wants me to touch the bottom of the shelf because it's going to locate the shelf pin there. And then finally pick the axis that I'm riding on, which are the 2 work planes. So whether I put 4 sets or 40 sets in, it's doing it all at once. Again, saving dramatically in the amount of time that it takes to accomplish the task. As you can see, I'm riding on the work planes. The grommets are placed on all 4 vertical surfaces. This is done after the fact, so everything lines up. I didn't have to worry about it in my design process. I did this afterwards. And they're parametric, of course, so they'll move up and down. They'll move based on where the shelf is. You can see that the pins line up right underneath the shelf. I didn't have to worry about constraints. It's doing this somewhat automatically. And downstream, if we move the work plane from 2 inches in from the front, and we say it's 1 inch in from the front, you'll see that the pins, all the pins move with it at the same time. Again, we feel this is a real game changer, the ability to do this all at this late time in the game. At this time, I would like to add some joinery. From my library, I'm going to place a couple of cam connectors, and these are used when the furniture or whatever we're building is knocked down. It comes in a box, put it together. And from our library, we have some mini connectors, and as my shelf pins, the mini connectors are an I family, allowing me adjustment on the way in. So in this particular situation, I'm saying I can have a left dowel or right dowel for location, or both, excluding whichever way I want to do it. Also, what the length of the bolts are, all the different configurations that the manufacturer gives me the opportunity to use. And as before, using glorified iMates, I can attach this particular hardware multiple times at once. Again, it prompts me for where do I want to attach it. So I'm going to attach the connection plate to the 2 large vertical surfaces. So I just rotate my model and touch it. Whether there's 2 or 200, it doesn't make a difference. The next item, it will be, where do you want the cam? The cam, of course, is what it allows you to tighten up the 2 pieces together with usually a screwdriver or some tool. And I'll pick the 2 long horizontal surfaces because I want to hide it. And then the axis is going to be the same axis that we use for the shelf pins. So I pick the 2 planes that are already there, hit attach, and it's done. Keeping consistency, shelf pins, hardware, everything's lining up. So when I'm done, this will be very easy to fabricate. You can see we hid the connectors underneath the top surface. If I turn off the shading, you can see that they're already aligned. I did not have to constrain one individually. This is all, again, being taken care of with this type of workflow. If I want to change the location by changing the work plane, of course, this changes that location also. Now, we haven't touched on the center unit either, also the center vertical rail. And the cams are on the different locations, so we're going to do it at a second time. So the first thing it asks me for is the connection plate, which is what I'm picking, where the cam goes, and then again what the axis is, and I'll touch the same axis. So these work planes can be used over and over and over again in the process of creation of our joinery that is necessary to build with. If I wanted the cam plate on the other side, I would have picked the other side. So as you can see that when I go into wireframe, that everything is done correctly the first time. Things are lining up. And any item can become a library item. So it doesn't even have to be an Inventor part. I can grab anything in any 3D format because Inventor can read those 3D formats and reuse it in our world. So many of the tools that I have come up with are really, they're not even Inventor parts when they start out. I'm going to save my job. Okay, again, try to save often. And we're almost through. Our next steps are going to be is to possibly add our hinging conditions in this particular situation. Our next step in the process is to add some European hinges, some hidden hinges into this particular cabinet. And as before, again, we're going to go back to our library and we're going to grab some hinges, some concealed hinges. We'll do a standard door hinge, an insert or dual hinge. And of course, building a library is very important so that we don't have to spend our time reinventing the wheel. Just like blocks in AutoCAD, we will have them here. And as before, they come in as I-families, and thusly we can change them, manipulate them, do whatever we want with them, all the different variations that we might have. And if you take a look at this particular European hinge, you'll see that they come from read-only libraries. So again, you can inadvertently change them. And they'll actually have the screws associated with it. You'll also see the cup has a blue tinge around it, so it's going to cut into the door. All those things are part of the library item, and there's some pre-planning. Now, as before, we're going to create some work planes, and we'll say the work plane is 3 inches from that bottom shelf and 3 inches from the top. Now, these work planes are perpendicular to the other ones, because we're going to be applying the hinge a little bit differently than the shelf pins and the cam connectors. Again, utilizing the same tools as we did before, we're attaching the hardware. It's asking us different questions. Where's the mounting plates? So the mounting plates will be on the 4 vertical members. If they're all the same at once, now they don't have to be, but in this particular case they are. What's the edge or the front edge of the cabinet itself? It's going to place it there. And then what axis do you want to ride on, which of course will be those 3-inch work planes. So what we're doing here, we're putting in 8 separate hinges all at one time into our particular job. And of course these are parametric, so if the cabinet grows, the hinges are always going to stay 3 inches from the top, 3 inches from the bottom, certain distance off the front no matter what. Again, a very, very sweet tool to be able to do the work after the fact. Once everything else is already approved and designed, you're just building the hinge or placing the hinge. When we're finally done, you will see that all those pilot holes will exist in our presentation before fabrication. Okay, we can turn the work planes off. Again, all of these are using very standard Inventor workflows except for the attachment, which has enhanced the way that we actually work through any particular project. Normally at this time I would probably go to the library, grab the doors that I want to use, and then just attach it to the existing hinge condition that's there. But I'd like to show the group how to use Adaptivity in this particular project. So we'll get back to the cabinet. First steps in the process is to create a work plane that's centered on the shelf. And the purpose of that is I'm going to be creating 2 doors for each of the openings that I want them centered. The second step is to create a new door. So we'll call it door A1, pick OK, and we'll place it right on the face of the hinge. I know that it's going to line up perfectly on the hinge itself. And then from there, I'm going to just create a rectangular shape that I don't even dimension. I just place it there and give it a thickness of 1/4 inch, 1/2 inch, 1 inch, what have you. From there, I'm going to turn on Adaptivity. Okay, so once Adaptivity's on, it'll allow me to stretch this into place. So by just picking the particular different components or the work planes, I can say that it's a 1/16 of an inch off of it. Again, normal constraints at this point. I can say that the left-hand side is flush to the left-hand side of the cabinet. And again, you'll see that it'll stretch. And the bottom of the door is flush to the bottom of the locked-in horizontal rail. So that's completed. At this point, you can see that this particular door fits pretty well, and we're faced with looking at the different positions. It has offset the cabinet based on the hinge, and our next step in the process possibly is to create the second door. So almost a repeat of the first door. Hit OK, place it where we would like it, which is on the hinge, of course, and then go ahead and create a rectangle again. Now, Adaptivity is fairly simple to use. It's been around for quite a bit of time with Inventor. You just go to the browser, right click on the extrusion, change Adaptivity, and it's on. It's an on-off switch. And then from here, we go back to the assembly, add our constraints, and flush it up. Now, whether this is a panel door, whether it's a flush door, whether it's got detail on it, a lot of this is very consistent. For the most part, I have all my doors already done, and because they're iFamilies or they're using iLogic, it allows me to bring it in, change their size, and I don't have to think about it in the construction of any of the projects that I work on. The goal is to build your library as well as you can so that these things just don't take time. Each of these particular items a couple of minutes at the most, and we can focus and concentrate on the actual construction or the design rather than the details of building this piece of hardware or what have you. So again, I'm just going through it, adding constraints. Keeping a clearance between the doors. And again, this is if the doors don't exist. So again, pretty consistent door for what we're going to try to accomplish here. Save our work. Now, to do the right-hand doors, again, it's fairly simple. We can do a cut and paste. We can rotate the doors into place. And then we can add constraints. Again, I'm trying not to rotate the model too much. The more you rotate it, the less work you're doing. And again, I'm taking the left door, rotating it around for the right door, and so on. And within a couple of minutes, I'll have created both sets of doors with the clearances on both. So again, maybe 5 minutes to create this set of doors, or as I said before, a library. Keep my clearances consistent all the way through. Now, the big change starts happening when I go back to the master, change the value of the master in its width, in its length, in its height, do an update, change the depth, all the things that we've done before. Change it here in the master, go back to the assembly, and then just do an update. And if everything is done properly, the cabinet just adjusted. What this means is that you can create one master, use it over and over again in multiple configurations, and everything just updates for you. So Adaptivity allows for the change of the model without any parameters whatsoever on that particular item. One of the next steps is, let's say that these are made out of solid material. So we'll go back to my material group. We'll say OK. And then we'll say that it's made out of whatever material I decide upon. And here we have a listing of the different materials. Again, some of this we've already discussed, but I like to just show them the workflows. And we'll say it's made out of some sort of chipboard or mica, or what have you. And I just hit OK. And it has adjusted, it'll adjust the front doors to that material. And of course, it'll become part of our bill. If we take a look at the bill of material that is now associated with our project, you'll start seeing that things are starting to change. More parts in our system, not only doors, but also hardware, have been added. So we take a look at that, you'll see that we see the two doors, quantity, size, thickness, and we just stretched that into place. That's all we did. So we know exactly what it is. And then we know the material that we used. And of course, we also see the hardware that's been added and how many pieces of hardware, how many wood pins, how many cams. Everything is being associated at this moment in time. And then if we go out to the spreadsheet as an export, you'll see that not only do we have parts lists based on things we're building, but we also have a tab that shows the assembly of hardware, the total assembly plus the hardware. So lots of different ways of presenting output from our simple project, and it's also categorizing it based on the materials used. So parameters or information built in Inventor definitely can go and be exported out to a spreadsheet or beyond. We have quite a number of companies that take this and go out to optimization, all types of tools that really start the process of fabrication. And this is just one of those tools that you might consider in the usage of Inventor in your world.